Start. 1, 0, and liftoff.
The whole world is reaching for the stars. Over the next decade, roughly 9,000 satellites will be launched into orbit, compared with just 1,480 over the last 10 years. These satellites will change our lives in so many ways, from delivering more accurate navigation technology to helping supermarkets identify whether the fish they are buying were caught in legal waters. The market potential is huge, and Britain, once the world's third spacefaring nation, but today ranking in the bottom third, wants to get back in the race. The UK can already boast world-beating expertise in communication and small satellite technology. Thanks to the persistence of 3 British engineers, we may also be at the cutting edge of propulsion technology, with an engine being developed by a small but rapidly growing company in Oxfordshire that promises to revolutionize access to space. In a closely guarded lab in Oxfordshire, Reaction Engines of the UK is working on a groundbreaking engine that promises to take an aircraft from ground to orbit and back again at hypersonic speeds. If successful, this could radically alter the economics of satellite launches.
Single stage to orbit, fully reusable systems are the ideal state, the holy grail, and a point that many people are aiming for. But I think it's a huge leap to take from today's conventional rocket technology and the efforts at reusability there to a fully reusable single stage to orbit system.
Reaction's innovation has been to combine successfully jet engine and rocket technologies. And it is the unique heat exchanger, made up of thousands of tiny tubes which cool the air rushing in at temperatures of 1,000 degrees Celsius or more, that make the whole system work.
So the problem with flying fast is that the air gets very, very hot. So at sort of Concorde speeds at Mach 2, the air is only about 100 degrees centigrade. At Mach 5, because the temperature goes with the square of the speed, the air temperature reaches 1,000 degrees centigrade. Which is too hot to send directly into the engine. So the whole idea behind the Sabre engine is that we use the fact that we've got liquid hydrogen fuel on the vehicle, which is at a very low temperature, as a coolant to cool the air, to the point where we can then compress it in an ordinary sort of jet engine style compressor.
The genius has been to miniaturize the tubes beyond anything achieved so far.
The scale in which we're employing material is microscopic, so we're going to levels where we are metallurgically down to just maybe a handful of grains across the wall thickness. And so, for example, with the tubing that we're using here, we are down to the scale of perhaps half the human hair thickness. In fact, we're aiming to go quite a bit below that. Well, one of the big problems that we encountered very early on is the fact that when we are using tube of very, very fine gauge, that some of the wall thickness would simply disappear in the process of joining because it's a very hot and a very aggressive process.
This year, Reaction will begin building its first full-sized engine, a demonstrator to prove that the complex cooling system works successfully with all the other parts. Making the Sabre engine fly will be the culmination of a life's work for Reaction's 3 founders, Alan Bond, Richard Varville, and the late John Scott. Known to their friends as the 3 Rocketeers, they quit their day jobs to pursue their dream of space travel. When the UK government pulled funding for an earlier space engine project, the 3 decided to set up on their own.
I was terrified that we'd built such a lot of technology during those few years, and that was going to get lost. Richard Varville was really the instigator of setting up Reaction Engines. I said to him, well, there's no money, how are we going to do it? And he said, I don't care, we're going to do it. And so he was the first one who jumped out of his job at Rolls-Royce, and then I followed him into a completely empty pool, and we spent many years trying to find people that would be prepared to put even small amounts of money into Reaction Engines so that we could continue to develop the theoretical side of it, but also with some limited experimental work. Bit by bit, we managed to sort of keep the project alive.
Nearly 30 years later, their dream is becoming reality, but it hasn't come without sacrifice. New management has been brought in and compromises have been made.
For me personally, actually standing down from running the company was quite a hard choice, and I've done my best to I hope, support the people that have taken over. But the company's had to make the transition from being a funny little research company out in the depths of Oxfordshire to being one of the aerospace companies up there, rubbing elbows alongside the big aerospace companies.
The technology has drawn interest from the US government and global industry, but it still has to prove that those miniature tubes will work.
It is quite a complex system which requires a number of technologies to come together, both novel and off the shelf. The world is our oyster if we can pull that off, because it is a demonstration of something that's truly revolutionary.
It's hard not to get excited about the technology being developed here today. Reaction Engines has the potential to be one of the UK's most innovative aerospace companies of the next generation. But it'll be another decade before a Sabre engine flies into orbit. It's clear there are still many hurdles to overcome. Peggy Hollinger, Financial Times, Oxfordshire.